So coming to the most important and repetitive problems on practical transformer is operating under load conditions. And follow my classes. Definitely you will get good score in your university examinations. Don't skip and don't fast forward. Listen carefully, solve this problem and utilizes my classes. Definitely you will get good score. A 2200 by 200 volts transformer takes 1 ampere at the HT side, that means high tension side or high voltage side, on no load at a power factor of 0.385. So this current is called the no load current. This is the primary induced EMF and the secondary induced EMF, and the power factor under no load condition is 0.385. Calculate the iron losses. What is iron losses? If a load of I2 is equal to 50 amperes at a power factor of the no load power the load power factor is 0.8, lagging means that too RL series load is taken from the secondary of the transformer. Calculate the actual primary current and its power factor. So he is asking what is I1 and what is the power factor. Cos phi 1 is how much? So this is the problem. So in a given data, E1 is equal to 2200 volts, E2 is equal to 200 volts, the no load current is 1 ampere, and the no load power factor cos phi naught is 0.385, lagging, and the iron losses is how much? The first one is iron losses how much, and these are the no load conditions, and the load current is 50 amperes, and the cos phi 2 is 0.8 lagging. So the iron losses formula under no load condition, V1 I naught cos phi naught. So this is called the V1. V1 is 2200 into the no load current is 1 ampere and the power factor is 0.385. So by using calc, if you solve this, 2200 into 1 into 0.385 is equal to 847 watts. This is about the iron losses. So if you draw the phasor diagram, you can easily understood. So this is a supply voltage, V1 is V1, the magnetizing component of current, and flux. The induced EMF in the primary and secondary winding is E1 and E2. Okay, and the V2 is small angle is not given. With respect to V2, the I2 current is lagging here. So before that, you should represent the wattful component of current by adding these two. Will give the no load current. Once the current is flowing through load, which will produce a secondary deflected current, that is I2 dash is equal to K times of I2. So by adding these two vectors, then I will get the resultant current I1. So but if you want to solve this problem, you should thorough with the phasor diagram. The angle between V1 and I1 is called the primary power factor angle, and the angle between V1 and I2 dash is called the phi 1 dash, and this one is phi 2. The angle between V1 and I0 is the no load power factor angle. So this one is no load power factor angle. So how can you calculate the K? K is equal to E2 divided by E1, that is 200 divided by 2200. 200 divided by 2200, that should be equal to 1 by 11.0909. For I2 is equal to 50 amperes and the I2 dash is equal to K into I2. So multiplied with 50 to the K, then I got the 4.45 amperes. That means 50 into 0.909. So 50 into 0.909, so 4 point. After that, so we know that phi 1 dash is equal to phi 2. Cos phi 2 is equal to, this means this phi 2 is equal to the angle between these V1 and I2 dash. It is 0.8 lagging. So from this you should calculate phi 2 is equal to cos inverse of 0.8, that is equal to 36.86 lagging. Okay, we know that what is I0? I0 is equal to 1 ampere and the no load power factor cos phi 0 is equal to 0.385 and cos inverse of 0.385. So that should be equal to 67.35 degrees. This phi 0 value is 67.35 degrees and this phi 1 dash, so this phi 1 dash value is 36.86 degrees. So again it is a lagging. Now if you want to add these two vectors, now the primary current is a phasor sum of I1 dash bar plus I0 bar. We have a real component and imaginary component, that is I1 cos phi 1 plus j times of I1 sin phi 1, that is called the I1 dash sin phi 1 plus I0 cos phi 0 plus j times of I0 sin phi 0. Because every phasor has a real component and imaginary component, so you should add the real components. So these two and these two is also added, imaginary components. So I1 dash cos phi 1 dash, this is phi 1 dash only, plus I0 cos phi 0 plus j, you should take it as a common, then I1 dash sin phi 1 dash plus I0 sin phi 0. So what is I1 dash? Is 4.54 and the cos of 36.87 plus the no load current is 1 and the cos of 67.35 plus j, again it is I1 dash is 4.54, the sine of 36.87 plus I0 is 1, sine of 67.35 degrees. So finally I got the answer is 4.017 plus j times of 3.646 amperes. So this current is called the primary current. The magnitude of the primary current is 4.017 whole square plus 3.646 whole square. So finally I got it as root 29.429, that should be equal to 5.42 amperes. The current is 5.42 amperes. The phase angle, primary phase angle phi 1 is equal to tan inverse of imaginary part by real part. The imaginary part is 3.646 divided by 4.017. 42.22 degrees. Then the primary power factor cos phi 1 is equal to cos of 42.22 degrees. Then it should be 0.74. What is our conclusion points? He is asking the iron loss. I got it as 847 watts. The primary current I1 is equal to 5.42 amperes and the primary power factor is 0.74. It's called a lagging only. So this is the most important problem. Coming to the next problem. A single phase transformer with a primary winding voltage of 1600 volts with a ratio of, this ratio is transformation ratio of 8:1. So where K is equal to E2 by E1 is equal to N2 by N1 and the E2 by E1 is given as 8. So from this calculate E2. So 8 into 1600, that should be equal to 12,800 volts. And the primary voltage E1 is equal to 1600 volts. The transformer supplies a load of 20 kilowatts. So the output power is a load on a transformer. Load on transformer is equal to 20 kilowatts. And the power factor, the load power factor is 0.8 lagging. And takes a no load current of 2 amperes. The I0 value is 2 amperes with a power factor of 0.2, that is cos phi 0 is equal to 0.2. So if you draw the phasor diagram, V1, and this is the magnetizing component of current, and flux E1 and E2. So this is V2 is in phase by neglecting the small angle. The angle between V2 and I2 is called the power factor angle. I have a reflection coefficient is I2 dash. This is a wattful component of current. First of all, I am representing the no load current. This no load current is I0. So by adding these two phasors, then I get the resultant current. That resultant current is called the I1. The angle between V1 and I1 is called the phi 1, and this is phi 2, and this angle is also phi 1 dash. That is phi 1 dash is equal to phi 2. See the load. So power P2 is equal to V2 I2 cos phi 2, where I2 is equal to P2 divided by V2 cos phi 2. 20 into 10 to the power of 3 divided by, what is the V2 value? 12,800 into 0.8 is the power factor of the load. It is a lagging. So finally I got it as 1.95 amperes. What is the K value? The K value is 8. Then find out the I1 dash is equal to K times of I2. 8 into 1.95, that should be equal to 15.6 amperes. So here the I1 dash or I2 dash, so I1 dash or I2 dash is 15.6 amperes, and the I0 value is given as 2 amperes. So by using a parallelogram method, you can find the values. Or we know that phi 1 dash is equal to phi 2 is equal to cos inverse of 0.8. So in the previous problem also same power factor is given, 36.86 degrees. The no load current is 2 amperes and the cos phi 0 is 0.2. The no load power factor is 0.2 lagging. From this, phi 0 is equal to cos inverse of 0.2. The cos inverse of 0.2 is 78.46 degrees. So again the same story. Now the primary current Now the primary current I1 is equal to I1 dash bar plus I0. So it has a active component, reactive component. So I1 dash cos phi 1 dash, then I0 cos phi 0. I am separating the real component and imaginary component. J times of I1 dash sin phi 1 dash plus I0 sin phi 0. Then 15.6 cos of 36.87 plus 2 cos of 78.46. Then 15.6 j times of 15.6 sin of 36.87 plus 2 times of sin of 78.46 degrees. So finally I get the 12.88 plus j times of 11.32 amperes. This is called the primary current. Find the magnitude and phase angle. So it is a root of 12.88 whole square plus 11.32 whole square. That should be equal to 17.147 amperes. And the primary current is 17.147 amperes. So if you want to find out the primary power factor angle 11.32 by 12.88. So shift tan inverse of 11.32 divided by 12.88. Then I get the answer is 41.31 degrees. So from this I can calculate the cos phi 1, that is the primary power factor angle. So that is 0.751. So like, okay, so these are the most important problems on practical transformers operating under load conditions. So coming to the next important problem, a transformer has a primary winding of 800 tons, that means N1 is equal to 800, and secondary winding of 200 tons, that is N2 is equal to 200. When the load current on the secondary is now I2 is 80 amperes at a power factor 0.8 power factor line, determine the no load current. See, here he is asking no load current of the transformer and the phase angle with respect to the voltage. Assume that the primary current should be I1 is 25 amperes and the primary power factor angle is 0.707. So N1 is 800, N2 is 200 tons, I2 is 80 amperes and the cos phi 2 is 0.8. I1 is equal to 25 amperes and the cos phi 1 is equal to 0.707 lag. So how we can calculate the transformation ratio? K is equal to N2 divided by N1. 200 by 800. It is a step down transformer, right? So that is 1 by 4. So E2 by E1 is equal to N2 by N1 is equal to K, and the I2 dash is equal to K times of I2, that is 1 by 4 times of the secondary current is 80 amperes, that should be equal to 20 amperes, and the cos phi 2 is 0.8 lagging and the phi 2 should be equal to 36.86 degrees. Okay, and the cos phi 1 is equal to 0.707 lagging and the primary power factor angle is cos inverse of 0.707 is equal to 45 degrees. Again you should draw the phasor diagram. V1 and the magnetizing component of current is lagging with respect to voltage by 90 degrees, and here it is V2 with respect to V2, I2 is lagging at an angle of phi 2, The watt-full component of current is in-phase component. The resultant current is no-load current. This is I2 dash is equal to K times of I2. So by adding these two vectors, then I got the primary current. This is primary power factor angle. The angle between V1 and I0 is called the no-load power factor angle. So again the same procedure you can use it. I1 is equal to I0 bar plus I2 dash bar. So I1 is I1 cos phi 1 plus j I1 sin phi 1. I want to calculate the no-load current. The cos phi 1 plus j sin phi 0 plus I2 dash into cos phi 2 plus j sin phi 2. So I0 into cos phi 0 plus j sin phi 0 is equal to I1 into cos phi 1 plus j I1 sin phi 1 minus I2 dash into cos phi 2 plus j into sin phi 2. Substitute the values. 25. The primary power factor is yes cos 45 plus j sin 45 minus the I2 dash we are already calculated, that is 20 cos 36.86 plus j sin 36.86. So from this I am getting as 1.675 plus j times of 5.675. The resultant no-load current, magnitude of the no-load current is 1.675 square plus 5.675 square. Then I got it as 5.91 amperes. He is asking the no-load power factor also, where phi naught is equal to tan inverse of 5.675 divided by 1.675. That should be equal to 73.55 degrees lagging. And the no-load power factor is cos phi naught is equal to 0.283 lagging. Because the phi naught you can substitute here directly, you are getting cos phi naught, that is 0.283 lagging.